Okay, let's continue. The last problem was such a problem that 57% of students could do this in the first test. But I think now everyone can solve it. I think so. Then I have order. There is 18, problem 18, which is also solving an equation. And it was this kind of equation. I will show it first here. 18. Solve variable x from the equation, and there you see. So there are some kind of fractions in both sides of the equation. And let's look at that. X minus 3 divided by 2 equals minus 2x plus 1 divided by 5. This problem was solved quite many ways. Some likes to do this so that they see those numbers in bottom of both fractions. There are 2 and 5. So if you multiply this left hand side by 5 so that both top and bottom are multiplied by 5, you get 10 here. 2 times 5 is 10. And if you multiply this right hand side of this equation by 2, then you get 2 here, and 2 times this expression here in the top part, and 2 times 5, which equals also 10. Then you have 10 on both sides of equation in the bottom. And if you have the same number, for example, if you had 5 here, you have 5 here and 5 here, then this equality is correct even if you take away those bottom parts of, if they are same. But I don't think that is very nice way to solve this kind of problems. If you have fractions on both sides in equation, it is most easy way to solve this by cross multiplication. So I will use this kind of sign to show that you may multiply this 5 with this x minus 3, and you may multiply this 2 with this minus 2x plus 1. So this sign, which looks like some kind of cross, shows the direction of multiplication. So you get away from these fractions with this way. If you multiply 5 with this, you write this left hand side like this: 5 times x minus 3. You have to use these parentheses, or then you have to multiply immediately 5 times x and 5 times minus 3. But if you want to have this intermediate states, then you write this kind of expression with these parentheses. And the same handles with this another direction: 2 times this, 2 times minus 2x plus 1. And after this, you have parentheses, and you take those parentheses away by multiplying with this constant in front of these parentheses. So 5 is multiplied with x and minus 3, and here in the right hand side 2 is multiplied by minus 2x and plus 1. So you get 5 times x plus 5 times minus 3 equals, well, now let's have this multiplication sign. It is not necessary, but I write it there. And then here also 2 times minus 2x plus 2 times 1. It is useful to use these parentheses when you have minus signed number or minus signed expression there. And then we have 5x minus 15 equals minus 4x plus 2. And after this we have actually almost the same kind of equation as we had in this problem 17. They are quite near each other now. We continue with the same way as we did in 17, but we don't use now these intermediate stages there. We only move those x's to the left hand side of the equation and simple numbers to the right hand side of the equation. So this here will be moved to the left hand side, and this here will be moved to the right hand side. And remember to change the sign to the opposite. If you have minus, it changes to plus, and if you have plus, it changes to minus. So in the left hand side you have 5x. It has the same sign as before because it has not changed side. It has been all the time on the left hand side. But this minus 4x moves to the left hand side, so it becomes plus 4x. And here in the right hand side 2 stays there, so it stays 2 or plus 2, but this minus 15 changes the side and it becomes plus 15. Minus becomes plus. So we have here 9x equals 17. 9x equals 17, and as we did here, we had this kind of equation here. We divided by 17, or we divided with the factor of x. So here we divide by 9, and the final answer is x equals 17 divided by 9. So sorry, was that the question? I didn't quite, or was it only a mistake? Okay. And then I will continue. This was a problem. I like percentages. Was a problem which was correct 63% of students. It means about 2 students from 3 could solve this problem in the first time. And then the next one is number 3, problem 3, which is simplifying problem. it is quite near to problems 1 and 2, but there is a extra parenthesis, so there are parentheses inside of a parenthesis, a little small, a little bit harder, but not so very hard still. So I will write simplify the expression, and this will be an expression where there are A, B, and C letters. Tehtävä 3, exercise 3, or problem 3, tehtävä. That is T letter. Then A minus, and then we have 2 parentheses, 2A plus 3B minus 8C minus 3A plus 4B minus 7C. On Friday's test, this was a problem which was correct in 71 papers. And here we have these parentheses. Let's start from the inner parentheses. I mean these parentheses which are inside of these outer parentheses. So we don't do anything with these outer parentheses yet, but we only take away these inner parentheses. And here we have 2 parentheses, this first one here and the second one here, and there is one difference between those 2 parentheses. In front of this first parenthesis there are no any signs. This minus signs is for these outer parentheses, but in front of this first parenthesis here there are no signs. That means that the sign is plus. And if you have plus sign inside in front of parentheses, you can just take away those parentheses. They are unnecessary. But if you have minus sign like here, you have to take these parentheses away, but also change the signs. So here, these parentheses you just take away. This is one mistake which sometimes happens, that when there are many minus signs in problem and in front of parentheses, you somehow used to change the signs, but you have to always check that is there minus sign in front. Here it is, but here it is not. So here you can't change the signs, but here you have minus sign, so these signs are changed. So there will be plus minus plus, plus 3A minus 4B plus 7C. I will write there change of signs. In Finnish we call it merkin vaihto. Merkki is sign, and change is vaihto. So it is in opposite order than in English. Merkin vaihto, change of signs. And after this we have only 1 parenthesis left, so we can take them away, but remember that there are minus sign in front of those, so all these signs should be changed. You have to just be careful not to make mistake. So this minus changes all the signs. So here we have minus 2a minus 3b plus 8c minus 3a plus 4b minus 7c. It is not hard problem, but you have to be very careful. If you make mistakes, so the answer will be will be incorrect. And after this, you have almost the same situation than we had in this first problem, where we had only b's there, but here we have 4 letters A, B, C. Sometimes some of those letters can cancel out if there comes 0 to the factor. I will again use some color here. A, here is A, and here is A. So these will be A part of this expression. There will be 10 minus 2 minus 3. Then same thing for B part of this expression. There are B's here and here, and those who are left are C part. So there are minus 3 plus 4b. And the last part was the C part. There are plus 8 and minus 7. 8 minus 7. So what will be the final or the next expression? The factor of A equals 10 minus 5, 5a. Here comes plus 1. I will write it here plus 1. Maybe it's better like this. And then there is also plus 7. This is okay for answer, but mostly we don't write those ones there. So maybe better way to answer is 5a plus b plus c. But it is not a mistake. I don't think this is mistake if you leave those one factors there. It is okay for me at least. These problems have been in this test. These problems are planned so that in these easier problems you learn how to solve some kind of mathematical expressions or simplify some kind of mathematical expression, and when you come to a harder one, you can use that knowledge you have learned or you already know in these more simple problems. And that's also the thing in the problem 4, which is almost the same as, or actually there is some familiarity with the problem. Was it 14? If I can remember, yes, here 14. We had this 14 problem there, and if you could not calculate 14 correctly, it is quite understandable if you can't solve the number 4 correctly. You need that knowledge that we had in the problem 14. So simplify the expression. Sievennä lauseke. This is quite easy. Problem 4, tehtävä 4. We have here 1/2 minus 1/3 divided by 1/3 minus 1/5. So this is the beginning stage. And first thing we should do, I would say, is to get the same denominators, the same numbers in bottom part of these fractions. You don't need these all to be same, but in this parenthesis these had to be same, and in these parentheses these have to be same. And let's do it by multiplying this fraction by 3 and this fraction by 2. So what does that mean? We have here 1 divided by 2. If we multiply both of them by 3, we get 3 times 1, it's 3, 3 times 2, it's 6. This is the same as 1/2, 1 divided by 2. But we have now 6 in the bottom part. And here we multiply this by 2 with this number. So we have 2 in the top part and 6 in the bottom part. So now we have same denominators or same numbers in the bottom part of those fractions. Here we do the same thing, but we have now 3 and 5 in bottom part. So we multiply this fraction with 5 and this fraction with 3. And that is a way to get a 15 in the both bottom parts. So this will be multiplied by 5. It equals 5 divided by 15. This is same as 1/3, 1 divided by 3. And here we multiply these both numbers by 3. So we get 3 divided by 15. So we also get this 15 in the denominator in the bottom part. And then we have, of course, you can calculate more easily and more quickly, but I will go these calculation rules which are correct for problems in which you have only numbers. But these same rules are correct also when you have letters here in the problem. So here we have this common denominator 6. We can put it only with one division line, and then in the upper part we have 3 minus 2. So this is the rule. If you have the same denominator or same bottom number, you may use the calculation only in the top part of the fraction. So here we get 3 minus 2. And here we have the same situation. We have 15 in the bottom part, and in top part we have 5 minus 3. 5 minus 3. So this equals 1 divided by 6 divided by 2 divided by 15. And in this point of problem we have found the same kind of expression as we had in this 14 here. We had there only one fraction divided by another fraction, and here is the same situation. And we solved that 14 with this kind of way. We changed the double point there, or this division mark here, to multiplication mark. Jakomerkki, kertomerkki. Jakomerkki is division mark and kertomerkki is multiplication mark. We changed the mark here, division to multiplication, and then we changed the order in this fraction. Bottom part went to top part and top part went to bottom part. And it is called inversion of that number. So here we have 1 divided by 6, and now not divided by but multiplied with. Yes, there I have heard that there are some problems to join there. I will check if I am able to. Yes, I had one student asking for permission to. Yes, I hope these problems will be managed soon. When the first time to join is always the most hard. When we have most problems to join the online class, but I hope it will be better soon. So sorry for those who have had problems. We are trying to find out what is the reason for these problems. Not everyone can join right now, but if you know these students, just tell that these will be recorded, these lessons, so they can watch these later. I will add these recordings to Moodle after these lessons. It will take some time to move those to YouTube format, but it will be today. So here I changed the division mark to multiplication mark, and then I changed this order, so it will be 15 divided by 2. And then we I will write this with a common division mark. It is more easy to understand this reducing process like this. And here we have two numbers which are divisible to 3. So I can reduce or divide this 15 by 3. It comes 5, and I divide this 6 by 3. It becomes 2. So I will have 1 times 5 there in the top part, so it will be 5, and in the bottom part there will be 2 times 2, it will be 4. So it will be 5 divided by 4. Which book are we using was a question. Well, actually, we are not using any book. The material will be in Moodle, but I will give that only a bit by bit, not yet, because I know that there are many of the students who have had problems in these skills test in the beginning. So I will go through these skills test questions first, and let's see after that what we will be doing. So we have no book actually. I will, if I don't remember, did I, or everybody didn't see this in the beginning of the today's class. This is the online test we did on Friday, and these examples I am going through are from this skills test. So for example, this number 4 here, it is from here. It is the same, exactly the same problem as here. So this was the final answer to problem 4. This was actually done correctly by 60% of students who made that test. So it was 3 out of 5 who could do this correctly. Someone had a half point from this problem if they when I have given the results of this test, and probably that was because of not reducing the final answer. So there will be probably 1 times 15, it will be 15, and 6 times 2, it will be 12. So if you had answer 15 divided by 12, that gave that 2 points. So sorry, half points of that problem. Yes, I I have noticed that you many times are asked to number 21 and 22 to 26, but I don't go to those problems yet. I will first go through these calculation rules, and after that I will go to those triangles. And today I will only go couple of exercises are left, which I will go through today, and then I give you some exercises to practice this, so you get a good how do I say, self what is that, where you trust to yourself when you are calculating these kind of problems. I'm sorry that probably for many of you I am going through these problems too slow, but at the same time I know that for some of you this is too hard velocity, or I am having to hurry in these problems. But I think these recordings will be helpful when you I will when I assign those recordings there to YouTube. I will tell in the name of the recording that what problems I am handling in those recordings, so you will find your problem there which you are interested in. Okay, so, problem 6 tehtävä 6, 6. Sorry, there. Simplify the expression, and there is powers. We haven't had in these earlier problems any exponents, but here we have. And let's see. It is somehow strange that this 6 was 69% of students made this correctly, but number 5 only 60%, and this number 5 is much easier than this 6, in my opinion. But sometimes it goes like that. But of course, there may be some mistakes, and as I have said, that not every time when you know yourself that you many times you know how to solve the problem, but you are lazy, or you make some mistakes that you never do when you are solving problems yourself, but in the test situation you make mistakes that you never do again or earlier have done. It is quite usual. So let's take this 3a, and then we have exponent minus 2m plus 3n. Then we have multiplication 5a to the power of 6m plus 7n. I don't like these kind of expressions. It is so hard to write that clearly so that everyone understand what I mean. And as I said, in the Friday's test, 69% of students could solve this simplifying problem. We have here multiplication, and here we have 3, and then we have this kind of a power expression, then we have 5, and this kind of power expression, and this is multiplication, 3 times this times this times this. So there are actually 3 multiplication signs or marks here, but they are not shown here between this 3 and a and between this 5 and a. But as you know, when you have multiplication, you may multiplicate in whatever order you like. So in this example, it is okay to change the order so that you have 3 and 5 in the beginning, like this. And then you may write this other part here, like this. So I only changed the order of the multiplication. By the way, I've noticed that there are some I think differences in mathematical culture. In Finland, we usually use these multiplication marks like this, that they are in the middle of the numbers. But I've noticed that in many foreign students, when they calculate, they use these multiplication marks like here in the bottom part of the number, and it's the same thing, but I usually put it like this. I think most common error in this problem was that somehow you forget that you had this 5 here. So I don't remember the number of those mistakes, but it is quite huge. So many of you knew how to solve this, but you made some small mistake there and forgot some number. So here we have 3 times 5, so it is 15. And then we have this common here, a and a. And with a's we have different exponents, different power. But as we have, for example, I write this here, compare. For example, if you have 2 times 2 times 2 times 2 times 2, you may write this 2 to the power of 2 times 2 to the power of 3. Sorry, 3. I hope you see it, that this is number 3, 1, 2, 3. And if you, so this two part here, first part here becomes this, and these 3 here becomes this. And if you now watch those exponents there, you may calculate them or add them. So you have 2 to the power 5. And it is correct because there are five number 2's in this multiplication. What I wanted to say, that if you have the same number here, 2 and 2, you may, and they are multiplied with each other, then you can do so that you add these exponents there, 2 plus 2, 3. And here we have the same situation. We don't have 2 there, but we have the same number or same letter there. So we may use the same rule. We take the a here, and then we add these exponents together. So we have this minus 2m plus 3n, and then we add this minus 6m plus 7n. This is the most important part of this problem, to notice this. And it is the same rule as it was in this simple number example. You may add these exponents together. And after this we have 15a, and the exponent for a is, there are m part, minus 2 and minus 6, that is minus 8m, and then we have n part, there are plus 3 and plus 7, it is plus 10, so it is plus 10n. So in this problem, most important part was that you notice that you may change the order of the multiplication. So move this 5 to the beginning of this sentence or this expression, and then you have the same number here, but different exponents. You may add these exponents together or sum them, so you get the common exponent there. It is actually the same rule as in this simple number example. I don't like the letters M and N. They sound so similar. In Finnish they are almost the same, but we use the A letter there. It is M and N. M and N. That was the numbers problem 6. And then I as I said, it is strange that this 6 was made better than in this problem 5, and this 5 is one of the simplest in this test. But there is one origin of error, and it is the last part of that expression. There is only this x, and I think that is the most usual. Sorry.
Yeah, I have a question on
Yeah.
test
Kuus.
the previous one that you have just done.
Yeah.
I see there was a 3 times 5 times 8. Where did the other 8? Why does it not appear in the final answer?
This multiplication.
Yes.
Yeah.
I see there's an A, right, and yes.
Hit that. Yeah.
That one disappeared too.
Yeah. It's because of. Wait a minute. I will try to find my formula book. I will show from that. It's easy. Unfortunately, this is Finnish formula book, but I will show still. It is where do I find here? This is the rule. There are exponents r and s there, and you may add those exponents. So you can use only one a here, and then sum those exponents together. It is the same as here, that when you have 2 number 2 times 2, it is same as 2 to the power 2, and here these 3 2's multiplied together, it is 2 to the power of 3, and here also you may add those exponents, 2 plus 3. Yeah. Yeah, thank you for the question. I will add that to my material, because you probably are not the only one who had problem with this or did not understand my expression. Yeah. And then yes, it was the problem 5 I was going to handle next, and it was this kind of expression. There are only x's there, but there are different exponents, and then there are also number coefficients or factors 4 and 3 there, and I will write it there. X and exponent is 3 times 4 x to the power of 2 times x to the power of 4 times 3 to the power of, sorry, 2 times 3x. And this was a problem which was calculated correctly from 60% of students. So about 3 of the 5, or exactly 3 of the 5, could calculate this correctly in the first time. And the most common error becomes from this last part of the because there are no exponents shown in this x. But you may think that if you don't see any exponent there, then the exponent is 1. So I will write this again, the same expression, but I will add the exponent to the last part. So here you don't see the exponent, but I will write here 1 to the exponent. I will write it here. This is actually the reason why I have added this problem to the test, because this is quite usual mistake which students may make, and also I make. It is it is so easy to calculate these numbers, to add these numbers 3, 2, and 4, but then you forget that there are also number, even though it is not shown there. And what I wanted to note here is that x is same as x to the power of 1. It is same as, for example, 7 is the same as 7 to the power of 1. And then we may do the same thing as we made in this problem 6, where we changed the order of the multiplication, and it is also possible to do same in here. And we have these number coefficients there, or factors. There are 4 and 3, and we may put them in the beginning of the sentence or expression, and then we may write those x's here: x to the power of 3, x to the power of 2, x to the power of 4, and x to the power of 1. It is not necessary to change the order. You may just find those numbers here. So here is 4 and 3, and you may calculate 4 times 3 is 12, and write immediately write there 12 to the beginning of the sentence or expression. So we have 12 here. But then we have same letter here, and we have exponents 3, 2, 4, and 1, and we add those exponents together. We have 3 plus 2 plus 4 plus 1. And that is, if I got correctly, it's 10. X to the power of 10. Most common wrong answer to this problem was the same, but the exponent was 9, and it is usual error, and it tells that if there are no sorry, is there a question? Okay. Okay, now yes, so this is important thing. Notice one thing which was not in this problem, but where do I see that? We have here you may have some formula books or which have the same rules there, but maybe some in different letters. But this is important to notice, that if you have the exponent of 0, for example there, a to the power of 0, it equals 1. So whatever number, if it is increased to the power of 0, that becomes 1. It can be you may remember it, but it is also quite easy to show that why it is like that. why the rule goes like that. I will not do that right now, but maybe later I will write some example of this which shows that it has to be like that. If you have a number which is increased to the power of 0, that becomes 1 always. Well, one number 0 when you get that to the power of 0, you get nothing. I will show from my calculator that 0 to the power of 0, there comes text undefined. That is not possible to calculate at all. And actually, I've never had any idea why would someone like to calculate this kind of uh, problem. Yes, that's correct. Yes, you there was written that some important rules with us notes. Yes, that will be done. Yeah, good. This book which I saw, it is a Finnish formula book, tekniikan kaavasto. Kaavasto means formulas, and tekniikan means technology. But if you have some formula books, I think from your own country, I think they are correct. They are okay. I'm not sure if this is any good formula book, but this is a book that most of our students buy when they start their studies. There are also other formula books, but this is enough. And then the last example today, which I will go through, and after that I will give you some exercises to practice your knowledge. This is number 8. Simplify the expression, and there you see 5. There was a question, what is rectangular triangle? I will answer that. It is another name for this kind of triangle. It is the same as right-angled triangle. Triangle which has one angle of 90 degrees. That is called rectangular triangle. Rectangular means that here we have a line, and this line is rectangular, so they are. Yes, right angle triangle is another or third name of that triangle. Suorakulmainen kolmio in Finnish. Kolmio is triangle. But that last problem today is 5 times m plus 3 times m minus 4. Simplify this. This was problem which was made correctly by 69% of students. I would do this so that I wouldn't do anything with this 5 yet. I will leave that in front of this expression. But then I will open those parentheses by multiplication. This means I write there this multiplication sign, so this means actually this kind of multiplication. There are actually three numbers which are multiplied, 5 and then m plus 3 and m minus 4. They are multiplied, and the order of the multiplication is it's not, you may choose it freely. So it's for me it is easier to make first this multiplication, and then when I have this result of this, I will multiply that expression by 5. I think it is easier for me at least. And what will we do with these parentheses? We will multiply m with m, then we will multiply m with minus 4, and now we have multiplied this m with both of these. And then we take this 3 here, we will multiply it with m and minus 4. So there becomes totally 4 multiplications. M times m, m times minus 4, 3 times m, and 3 times minus 4. And now we use parentheses here, and this 5 is a factor which will be multiplied with this result which we get from this multiplication. M times m, I will write there only this multiplication first. M times m, m times minus 4, if you don't have any sign in front of m, it is plus. That's why there's plus. So m times m, m times minus 4, then we have plus 3 times m and plus 3 times minus 4. There we have multiplication m with m. It is actually the same as we had here, for example, this part here, 2 times 2. It is same as 2 to the power of 2. There was two twos. So here we have m times m, it is same as m to the power of 2. Then we have m times minus 4. There is plus sign and minus sign. There is only, in the multiplication, there is only one minus sign, or there is only odd number of minus signs, so 1, 3, 5, 7. If the situation is like that, then the minus stays. And here we have minus, because there is only one minus in the multiplication. And the number 4, I rather write it in front of m, so m 4 times m. It is this. Here we have 3m, so we have plus 3m. We don't need to use those multiplication signs there. And then we have 3 times minus 4, which is minus 12. Here the same rule. We have plus and minus, so we have only one minus sign. One is odd number, 1, 3, 4, 5, 7. So the minus stays. And now probably it is easier to now multiply all these by 5. So we have here 5 times m to the power of 2. So it is only like this. Then we have 5 times minus 4m. there is positive sign and negative sign, one negative signs, and it stays. So it is minus 5 times 4 is 20, and the letter after it is M. Here we have 5, and it will be multiplied by 3M. They are both positive numbers, so it will be plus, and 5 times 3 is 15, 15M. Dry pen. And the last one, 5 times minus 12. There is one, the positive number and negative number, so it will be negative. Yeah, 5 and 5 times 12 is 60. And then we find the similar terms here. So we have here m to the power of 2, and there are no other similar. So it will be 5m to the power of 2. Then we have these terms here where we have only one m part. We have minus 20 and plus 15. Minus 20 plus 15 is minus 5. So it will be minus 5m. And the last one is minus 60. So we only write it like here. And this is the last and I think most simplified form of this expression. So it was this kind of second order expression. M had an exponent of 2 in this expression. So I won't today do anything else, but I will open for you to practice some exercises which handle these first 10 problems which I went through today. I will open them to Moodle right after I have stopped this recording. I have to find where my Moodle is. I have 3 monitors here, but I don't find my Moodle anywhere. But I will stop this recording now and open the Moodle those exercises. I think you see this. I have made this kind of training series here to practice these problems which we had today, and you don't have to send me answers. There are correct answers here told, but don't watch those before you have calculated those problems. And this is only for practice. If you want to check if you know how to solve these problems, you may do it by this problem series. And there are also another series which is, I think the number was 3, training series 3, which handles the 5 next problem types. Yes. Can you explain the multiplication rules of plus and minus signs? Yes. Let's take again if I find my For example, if we have multiplication rules of plus, yeah, if for example we have this kind of multiplications, for example 2 times minus 3 times minus 5 times 4, for example like this. You have 4 numbers here which will be multiplied together, and you only count how many minus signs you have here. You have only 1, 2 minus signs, and the number of minus signs is the reason which gave the final sign. If you have even number, so odd number 1, 3, 5, 7, and even number 2, 4, 6, 8. If you have even number of minus signs, then you get plus. And if you have odd number of minus signs, then you get minus. Another, that's number of minuses. So for example, this example here, we have here 1, 2. And that means that we get plus from the result. And like this. I think it is 10, 12, 120, I guess, plus. And the same rule goes with letters. So for example, if you have A times minus B times C times minus D times minus E. And in this multiplication, you have minus signs 1, 2, 3. So it's odd number 3, 3. So you get minus. And with these letters, you don't have anything to do, because you have 5 different letters here, A, B, C, D, E. So you only write this A, B, C, D, E. You can't do anything more than that. Of course, you may put multiplication marks there, but usually you don't do that. I try to record every time when I write something to this paper. Sometimes I forget to start recording. This kind of triangle, in Finnish we called it suorakulmainen kolmio. Kolmio means triangle. if you know Finnish numbers, 3 is 3 in Finnish language, so that's where the name of the triangle. There are 3 angles in triangle or kolmio. That's why the name is almost the same as the number in Finnish language. And this suorakulmainen, this means rectangular or right angled. Dry pen. Rectangular, triangle, or right angled triangle. So it means that there are one angle which is 90 degrees. That means rectangular or right angled. Suorakulmainen. Kulma in Finnish, it is angle. Suora means it is, no, well, you may translate it right. Actually, right means in Finnish not left but right hand side. It is the sorry, I say in Finnish, right, you may translate it also oikea, and it means for example right hand. This is my right hand, oikea käsi, and this is my left hand, vasen käsi. And those exercises I gave you today, as I said, you don't need to send those to me, but if you have problems with that, you don't understand why you can't get the right answer, just ask. I will help, of course.